Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Dan selamat pagi. Okay. For today we are going to continue our chapter 9. Okay, with wave properties of particle. Okay, what is the wave particle duality? Okay, wave particle duality is a phenomenon where under certain circumstances a particle exhibit wave properties and under other conditions a wave exhibit properties of particle. Okay, so when we deal these two phenomena, that we deal with two categories of phenomena that we call a particle, which is a tiny object like bullet, electron, proton, neutron, and then they have mass and obey Newton's law, first law, second law, or third law. Okay, and then we going to wave. That wave are travel through an opening or around a barrier. That wave diffract and different part of the wave interfere. Okay, so kita boleh sambung kita punya subtopik. Okay, kita ada dua subtopik, yang mana subtopik yang pertama adalah berkaitan dengan 9.1 iaitu de Broglie wavelength. So our objective adalah yang pertama, okay, state wave particle duality, and then the second one is how to use de Broglie wavelength. Okay, so the formula is lambda is equal to h over p. Okay, according to the quantum story, okay, a photon of electromagnetic radiations of wavelength has an energy E equal to hf equal to hc over lambda. Okay, this is for the first equation. Okay, where the h is Planck constant and then c is the speed of light in vacuum. Okay, next, according to the Einstein theory of physical relativity, okay, that the energy equivalence E of a mass m is given by E equal to mc square. Okay, and then we have first equation and then second equation. We equate both, and then we can find that the hc over lambda is equal to mc square. And then we rearrange, and then we can see that the equation becomes mc equal to h over lambda. Okay, then we can find that the momentum p of a photon of wavelength lambda is equal to p equal to mc and then h over lambda. Okay, when p is a momentum of the photon. This duality also hold for matter. Okay, and then for a free particle with rest mass m moving with non-relativistic speed v have a wavelength lambda related to its momentum in exactly the same way as for a photon. Okay. Okay, this experiment, okay, evidence to show wave particle duality of light, that light can be wave, and then at the certain condition light become a particle. So the experiment show that the light exhibit as a wave is a Young double slit experiment and the diffraction experiment, and then light exhibit as a particle. We can see the experiment from the photoelectric effect and then Photon effect. Actually Photon effect ni dia adalah daripada serakan sinar X, iaitu X-ray. Okay. Based on the wave particle duality of light, okay, Louis de Broglie suggested that matter such as electron and proton might also have a dual nature. Okay. He proposed that for any particle of momentum p should have a wavelength lambda given by lambda is equal to h over p and then equal to h over mv. Okay, so kita lihat dekat sini di mana relationship between lambda and v is bila v tinggi maka lambda bagi suatu partikel adalah lebih kecil. Okay, so daripada formula tersebut kita boleh lihat di mana lambda represent for d Broglie wavelength. H is Planck constant, m is a mass of a particle, and then v is a velocity of a particle. So this wavelength, what we call d Broglie wavelength of a particle. So look at the example how to use d Broglie wavelength. So the question is in a photoelectric effect experiment, a light source of wavelength 550 nanometer is incident on a sodium surface. Determine the momentum and the energy of a photon used. Given the speed of light in the vacuum, c is equal to 3.0 times 10 to the power 8 meter per second, and the Planck constant that given is h equal to 6.63 times 10 to the power of negative 34 joule second. How to solve this problem? So we can find that the lambda is given 550 times 10 to the power of negative 9 meter, and then how to find the momentum by using the d Broglie wavelength. So lambda is equal to h over p. We just substitute the equation, substitute the information into the equation. Then we arrange the formula tersebut. And then we can find that the answer is 1.21 times 10 to the power of negative 27 kilogram meter per second. So how to find the energy of photon? By using the E equal to hc over lambda. We just substitute, and then we can find the photon is 3.62 times 10 to the power of negative 19 joule. So the d Broglie relation was confirmed in 1927 when Davison and German succeed in diffracting electron. We show that the electron have wave properties. Now we are going to the second subtopic, 9.2, electron diffraction. In this subtopic we have three objectives that we have to achieve after the class. First, describe the observations of electron diffraction in Davison German experiment. Second, explain the wave behavior of electron in an electron microscope. And then C, state the advantage of electron microscope compared to optical microscope. We go to the first objective. Davison German experiment. Figure below show a tube for demonstrating electron diffraction by Davison German. So dekat gambar rajah di bawah, kita boleh lihat di mana kita boleh consider untuk tiga bahagian. Yang pertama, dekat cathode, yang mana elektron beam terhasil dekat cathode. Lepas tu bahagian yang kedua adalah kita ada grafik filem. And then yang ketiga adalah hasil dia adalah pada skrin yang kita boleh lihat dia punya diffraction pattern tersebut. So In 1927, two physicists C.J. Davison and L.H. German carry out electron diffraction experiment to prove the de Broglie relationship. First, a beam of the electron in the cathode ray tube is accelerated by the applied voltage toward an extremely thin graphite film as a target. The second one, the beam of the electron is diffracted after passing through the graphite film. And then the third one is the diffraction pattern on the ring of rings is observed on the fluorescent screen. So kita lihat dekat sini, dia punya diffraction pattern dia adalah berbentuk cincin. Berbentuk cincin. Di mana diffraction pattern ini di mana dilihat hampir menyerupai serakan yang berlaku pada X-ray. So if the velocity of electron is increased, the rings are seen to become narrower, showing that the wavelength of the electron decrease with increasing velocity. So the velocity of the electron are controlled by a applied voltage V across anode and cathode. So from the conservation of energy, U is equal to K, kinetic energy, and then EV equal to half mv square. So dekat sini adalah hal laju bagi elektron tersebut. So kita rearrange the equation. So we can find that velocity is equal to square root 2 EV over m. E is here is for electron, V is a potential power supply, and the m is a mass of electron. So the de Broglie wavelength of the electron is lambda is equal to h over mv, and then we can find that the lambda is equal to h over 2 mev. Selesai untuk first objective, and then kita pergi kepada second objective, wave behavior of electron in electron microscope. So electron microscope, a particle device that relies on the wave properties of electron. It is similar to optical compound microscope in many aspects. So di sini kita ada dua jenis, two types of electron microscope. What we call, and the first one is the transmission electron microscope, and the second one is the scanning electron microscope. So how the wave behavior? In the electron microscope, electron are produced by the electron gun. The second, electron has accelerated by voltage on the order of 10 to the power of 5 volt, have wavelength in order of 0.004 nanometer. And then the electron are deflected by the magnetic lens to form a parallel beam, which then incident on the object or sample. And then the magnetic lens is actually magnetic field that exert forces on the electron to bring them to a focus. The field are produced by carefully designed current carrying coil of the wire. So kita boleh lihat dekat sini. Di sini adalah condensing lens, magnetic lens. Kita ada 3 bahagian. So di sini kita punya objek. And then ini adalah kita punya electron beam, yang mana kita ada magnet di sini yang akan control supaya electron beam tu dia akan penetrate kita punya objek. So hasil dia, image dia akan terhasil pada fluorescent screen. Then when the object is struck by the electron, more penetrating is some part or sample than in others, depending on the thickness and density of the sample. Okay, and then the image is formed on a fluorescent screen. The image is brightness where most electrons have been transmitted. Then the object must be very thin, otherwise too much electron scattering occurs and no image form. So untuk kita melihat image tu, kita kena pastikanlah kita punya sampel tu mesti nipis lah, dan supaya senang untuk elektron tu penetrate the object. Okay, so kita lihat kepada advantage objektif kita yang ketiga adalah untuk melihat advantage of electron microscope compared to the optical microscope. Okay, advantage of the electron microscope. First one, the advantage of the microscope of the optical microscope is the resolving power of the electron microscope is higher than that of the optical microscope. Ini sebenarnya yang paling penting. Okay, dia punya kuasa resolusi dia adalah lebih tinggi berbanding dengan mikroskop cahaya. Okay, ini adalah disebabkan oleh apa? This is because of the electron can be accelerated to a very high kinetic energy given them a very short wavelength. Okay, kat sini disebabkan oleh, kita lihat lambda dengan V, dia berkadar songsang. Kalau V tinggi, maka lambda dia rendah. Okay, so typically 100 times shorter than those of visible light. Therefore, the diffraction effect of the electron as a wave is much less than that of light. Okay, as a result, electron microscope are able to distinguish detail about 100 times smaller. Okay, jadi dia punya dia punya resolusi dia lebih tinggi. Okay, so kita lihat di sini comparison electron microscope and optical microscope. Okay, kita lihat di sini ada 10 dia punya item. Okay, so kita lihat yang pertama, surface structure, di mana mikroskop, electron microscope dia boleh 3D ataupun 2D, bergantung kepada jenis mikroskop yang kita gunakan, manakala optical microscope adalah 2D. Okay, so untuk resolution, okay, untuk electron microscope dia punya more power compared to the optical microscope. Magnification dia higher, and then optical is lower. Image bila kita menggunakan electron microscope, dia punya image dia adalah black and white, but then untuk optical microscope dia colourful sebab dia still dalam range cahaya nampak. So bila cahaya nampak, dia dalam 7 color lah. And then costing untuk electron microscope expensive, but then untuk optical microscope less. Okay, spesimen yang kita gunakan untuk electron microscope adalah that, and then optical is living. Okay, size of the electron microscope is large, maka dia punya space dia besar lah. And then untuk optical microscope small and lighter. Risk, okay, risk of the radiation leakage, no risk untuk optical. And then untuk radiation types, kita gunakan beam of electron, but then untuk optical kita gunakan sunlight. And then yang terakhir adalah image formation, so scattering of electron. But then untuk optical kita gunakan absorptions of light wave. Okay, so itu sahaja untuk kelas kita hari ini, dan selamat maju jaya. Assalamualaikum.